So welcome back to another exciting video which further explores the world of AI. Today we'll be studying about uninformed search. As the name suggests, uninformed, meaning there is not much guidance for the searching algorithm to explore the search space. These algorithms explore the search space systematically without any domain specific knowledge. That's why these algorithms are also known as blind search algorithms. Let's look at the formal definition of uninformed search. So by definition, an uninformed search in artificial intelligence refers to a search algorithm that explores a problem space systematically without any additional knowledge that guides it towards potential solution. In a nutshell, it simply means that these algorithms are not guided algorithms. They are not having any additional information that can guide it towards their goal. So let's try to understand what this algorithm is trying to say. Now suppose in an initial state I and I want to reach towards a goal state G. So as I am in initial state and I'm not having any additional information regarding the search space and I want to reach to the goal state. So in order to reach my goal state, I would systematically explore the entire search space and try to come up with a solution. And I would keep on exploring this search space till I reach my goal state. So this was the basic idea behind uninformed search, how these search algorithms work without any guidance. You'll understand them more clearly when we'll be discussing about various types of uninformed search, right? Okay then, if not additional information that could guide it towards the goal, then what information does it rely on for exploration of a goal state before starting the search? So these information includes the initial state, the set of actions in a particular state, the transition model, the goal test function, and the state space. So these are the 5 information that we would be having before starting our uninformed search. I have discussed all these terms in the previous video, but still if you haven't watched the previous video, then let me provide a brief understanding of all these 5 terms. So an initial state is the starting state from where the search begins. Actions. It is a set of possible choices that can be made in a particular state. Thirdly, we are having transition model. It specifies what resulting state can be obtained by performing a particular action in a particular state. Goal test. So it is a condition to check whether my present state is the goal state or not. Whenever we'll be reaching to a new state, meaning whenever we'll be exploring a new state, we'll be first checking whether it is the goal state or not. If it is a goal state, then our searching would stop. And if not, we'll keep on exploring the search space. And lastly, state space. It's a set of all possible states from initial state to goal state. So hopefully till now, you must have acquired some basic idea regarding this concept of uninformed search. Now we'll be moving on to the algorithm part. But before moving on to the algorithm, we need to be familiar with 2 terms that we would be using extensively while our discussion of searching algorithms in AI. So these 2 terms are, first is expansion and the second one is frontier. So let's start by understanding what is expansion of a state, and after that we'll be studying about frontier. So expansion of a state is also known as exploration of a state. In order to understand this concept of state expansion, you have to first know that whenever we study search algorithms in artificial intelligence, we represent the search space in the form of either a tree or a graph. For example, let's take this tree. In this example, we are having a tree-like structure where each node represent a particular state. So suppose I am in an initial state A. Till this point, I am unaware of this entire subtree. I just know that I am currently in the initial state. So first of all, I'll be checking, is this the goal state through my goal test function? If the answer is no, then I would be expanding this node, meaning I would be exploring who are the children of A. So after expansion of A, I would be getting these 2 nodes and the rest of the subtree is hidden currently. Let me name them as B and C. So this was the concept of expansion. We'll be exploring a particular node to check who are the children of that node. In this case, B and C are the children of A. These 2 nodes I would be adding in a data structure known as frontier. Whatever new node that I would be getting, I would be simply adding them to this data structure. It can be of a particular type, like it can be a queue and also it can be a stack. Let me consider it as a queue, or also there is a concept of priority queue. We'll be studying about all this, but for now, let's take it as a queue. So, so this node is already expanded, and the two new nodes that we have got is B and C. So as we know that queue works in a FIFO manner, first in first out manner. So I would be removing B from the frontier, and then I'll check whether B the goal state. Then we would expand this B, and when we'll be expanding this B, I would come to know who are the children of B. Let me erase everything. Now only this much area of the tree is hidden from us. Since we have expanded B, let me name them as D and E. So the new states that I have got, I would be adding them in the frontier D and E, and this process keeps on going. Similarly, I would be removing C from the frontier and first checking that is this the goal state. If not, again I would be expanding this node, exploring who are the children of C, and this process keeps on going till we find our goal state, assuming that it is not an infinite search tree and there exists a solution. So that's how we explore the search space. With that, now we are ready to explore the algorithm of uninformed search. First of all, I'll be talking about tree search. I am having a function uninformed tree search which receives the root node. Then inside the function, a frontier would be declared. This frontier can be of any type of data structure depending upon the usability of the search algorithm. For example, if it's BFS search algorithm, then we'll be using a queue, and if it's a DFS search algorithm, then we'll be using a stack. After declaring the frontier, we'll be adding the root node inside the frontier. So this was the initial setup for our uninformed search. Now the main working of our algorithm starts from this while loop from here to here. As you can see, it is having a condition that it will run until the frontier is not empty, meaning until the frontier is having some element inside it, the loop will not terminate. First of all, inside the while loop, we'll be removing an element from the frontier, and which element is going to be removed in a particular iteration depends upon what type of frontier you have taken. As you can see, I have mentioned over here. So the removed element going to be added to this node. Now we want to extract what state does this node represent. After obtaining the state, first thing that we'll be doing will be performing the goal test. As you can see, I am using goal test function inside this if statement. If this state satisfies this condition, then we have found our goal. Then we have found our goal. Then we'll be returning the solution corresponding to this node. Now, if this condition is not satisfied, meaning this state is not our goal state, then execution of this statement would be performed, in which we'll be first expanding our node, the concept of expansion that you have studied just now. So the same thing is happening over here. We'll be getting children of this node, which we'll be adding to this fringe. And this process continues. Either our goal test is satisfied or our frontier becomes empty. So, so if you think logically, if our while loop has terminated without any state passing the goal test, meaning the search tree does not contain our goal state. So in that case, I'll be returning no solution, right? So this was all about tree search. Now talking about uninformed graph search. The graph search is somewhat similar to this, except for some mild changes in the algorithm. As we know, in graph, nodes are somewhat interconnected to each other. So there can be chances that a single node might be expanded two times or more than two times. So this can worsen our time complexity. In order to avoid that, these are the changes that we introduce in our graph search algorithm. Rest of everything is same. Over here, I have declared a data structure named explode. Generally, it is declared in the form of a list, and initially it is empty as we have not explored or expanded any node till now. As you can see in this while loop, after the exploration or expansion of a particular node is done, we'll be adding that node to the explode list. Whichever node's expansion is being done, it will be simply added to this explode data structure. In between, in order to avoid an explode node to be added to the fringe or the frontier, we add a condition after the expansion of a particular node. Whichever new nodes that we'll be getting, they will be undergoing this condition. If they are not in the explode list, then only they are added to the fringe. So this was graph search algorithm. So this is the end of this video. Now we are completely ready to explore this realm of uninformed search. From the next video, we'll be talking about various types of uninformed search. So make sure you subscribe to it so that you can get notified of the new videos coming on this channel. So thanks for watching. See you in the next video.